Every year, billions of coconuts are harvested from the towering trees of the Philippines, supporting an industry worth billions of US dollars. Across the tropical islands, farmers climb tall trees or use long poles to cut down heavy coconut bunches before sending them into a nationwide processing network. At the factories, the coconuts begin their transformation. Coconut water becomes an exported beverage. The white flesh is dried, pressed into oil, or processed into food products. The rough outer husk is separated, cleaned, and turned into ropes, mats, and various eco-friendly materials. In 2024 alone, coconut oil brought the Philippines around $2.22 billion US. Yet despite this enormous value, millions of coconut farmers and harvesters still remain poor. Today, join Mandarin Tech as we uncover the paradox behind this billion-dollar coconut industry. Across 69 provinces in the Philippines, coconut plantations covering 3.67 million hectares have become a source of livelihood for more than 2.74 million farmers nationwide. What makes the coconut special is that it seems almost made to take root in this island nation. In coastal areas, people only need to prepare the ground, form the soil into small mounds, and plant coconuts that have already begun to sprout. From inside the rough shell, a young plant gradually emerges. It is cared for during its first few months until it becomes strong enough to adapt to the surrounding environment on its own. Coconuts do not require highly fertile fields or perfect growing conditions. They can still thrive in salty winds, intense sunlight, and powerful rainy seasons. This ability to take root in harsh environments has earned the coconut its name as the tree of life. But if the coconut is so closely connected to the lives of millions of people, why is most of its value created far away from the places where it is grown? Under the tropical sun of the Philippines, coastal coconut groves come alive at harvest time as workers take on the dangerous task of collecting heavy coconut bunches from trees reaching 20 to 25 meters high. The most traditional method is to climb directly up the tree. Coconut harvesters grip the rough trunk, climb dozens of meters above the ground, and use a sharp blade to cut through the stem of each bunch. Every movement must be firm, quick, and precise, because a single mistake could send the coconuts falling in the wrong direction or endanger the people below. Yet in many places, this dangerous work earns laborers only around $3 to $6 per day. In many coconut growing areas, farmers choose a safer method. They use a long pole fitted with a blade at the end to cut the coconuts while standing on the ground. The pole reaches into the canopy like an extended arm, separating each bunch from the tree without requiring anyone to climb. However, this method creates another risk. Falling freely from such a great height, the coconuts can strike the ground with tremendous force, crack open, and lose much of their value. For this reason, shallow water channels are dug between the rows of trees in some coconut groves. When a bunch is cut down, the coconuts fall into the water below. The channel acts as a natural cushion, softening the impact and helping keep the fruits intact. A single 50-meter section of canal can safely receive as many as 2,000 coconuts per day, significantly reducing cracking, which had previously lowered their commercial value by as much as 30% during harvest seasons. The coconuts floating on the water are then gathered and loaded onto small boats. However, each trip can usually carry only a few dozen fruits, making transportation slow and time-consuming. In some areas, workers use a more efficient method by tying the coconuts into long lines that resemble chains of green buoys drifting through the grove. Thanks to the buoyancy of the water, one person can use a single rope to pull as many as 200 coconuts to the collection point more quickly, with less effort and fewer losses. Once the long lines of coconuts reach the collection point, the fruits are pulled from the water and passed from hand to hand onto the truck. Each coconut weighs between 1 and 2 kilograms, so just a few hundred of them can create a load weighing nearly half a ton. The coconuts are stacked tightly in layers, secured firmly, and tied down with ropes to prevent them from rolling off the truck along rough dirt roads. As the engine starts, the heavily loaded vehicle leaves the coconut grove and winds between the rows of trees toward a collection center or processing factory. From a rough green coconut to a branded export product, much of its value is created by human hands. At the trimming tables, workers hold each coconut firmly with one hand while using a knife with the other to remove the thick green outer husk. Every cut must be strong enough to slice through the fibrous layer, yet precise enough to stop before reaching the hard shell or damaging the water-filled cavity inside. The bottom is trimmed flat so the coconut can stand upright, while the top is shaped into a pointed tip, giving whole packaged coconuts their distinctive appearance. A skilled worker can finish around 40 coconuts per hour, or one coconut in less than 2 minutes. The exposed white husk can quickly brown and develop microorganisms. The coconuts are therefore washed, then soaked for about 10 minutes in a solution of 10% salt and 10% citric acid to keep the surface bright and stable during storage. Once the coconuts have drained and dried completely, workers prepare the pointed top and attach a special cap for inserting a straw. This allows customers to drink directly from the coconut without using a knife. Next, a thin layer of food-grade plastic film is wrapped around the entire coconut, fitting closely to its surface while firmly securing the straw cap at the top. This keeps the product clean and makes it easier to use. Premium batches are then placed inside branded packaging printed with the batch number and product origin. The opening of each bag is inserted into a vacuum sealing machine. Within a few seconds, the air inside is removed, the packaging tightens around the coconut, and the bag is heat sealed. This protective layer reduces exposure to air, limits moisture loss, and keeps the white fibrous surface clean for longer throughout the cold transportation chain. At the end of the production line, the coconuts undergo a final inspection before being packed into moisture-resistant cardboard boxes. Each box usually contains 9 coconuts, held in separate compartments to prevent them from colliding with one another. Approved boxes are sealed, stacked on pallets, and transferred to cold storage maintained at between 2 and 5 degrees Celsius. At this production capacity, the factory can export around 20,000 coconuts per day to markets around the world. If coconut water is the freshest part of a young coconut, then in a mature coconut, the real value lies deep within its thick, fatty white flesh. As the fruit matures, the flesh becomes denser, the amount of water decreases, and more oil accumulates. This transformation turns mature coconuts into the raw material for one of the Philippines' most important coconut products. Along the processing line, workers separate the hard brown shell from the flesh inside, then use small knives to remove the dark skin still attached to the surface. Each cut must be close enough to reveal the bright white flesh, but not so deep that valuable material is wasted. Working at a rate of nearly 1 coconut per minute, a skilled worker can process around 50 to 60 coconuts per hour before the flesh is washed and transferred to the drying area. Under heat, the moisture inside the coconut flesh gradually evaporates, producing copra that is dry and light but contains a more concentrated amount of oil. The copra is first cut into smaller, evenly sized pieces, then passed through a grinder to create material that is easier to heat and press. The heated copra is fed into a screw press, where steel screws continuously twist, compress, and push it forward. As the pressure increases, pale yellow oil is forced out through narrow openings. From 1 ton of copra, a factory can obtain around 610 kilograms of crude coconut oil, while the dry press cake is reused as an ingredient in animal feed. The oil coming directly from the press is still cloudy and contains small particles, so it must pass through settling tanks and filtration systems. As copra fragments and other impurities are removed, the oil gradually becomes clearer, brighter, and more stable. Depending on the processing method, the final product may retain its natural rich aroma or be refined to achieve a lighter color and milder smell before flowing into bottles on the packaging line. The special value of coconut oil comes from lauric acid, which accounts for nearly half of its total fatty acids. With a production line processing 20 tons of copra per day, a factory can extract more than 13,000 liters of crude oil, turning the white flesh of mature coconuts into a high-value product. To produce coconut milk, the flesh must remain fresh from the beginning. Along the processing line, workers separate it from the hard brown shell, then use small knives to remove the thin, dark skin from its surface. Each cut must be close enough to reveal the pure white flesh, but not so deep that valuable material is wasted. This process is similar to preparing coconut flesh for oil production, but with one important difference. The flesh is not dried into copra. Instead, it is washed with high-pressure water and immediately sent to the grinder while still fresh, soft, and full of moisture. The white flesh is shredded into fine pieces, while clean water is added at a controlled ratio to release the natural fat, protein, and aroma from the coconut fibers. The mixture then passes through a pressing and filtering system. Under strong pressure, a thick, creamy white liquid flows out. Next, the coconut milk is sent to a homogenizer. This makes the product smoother, more stable, and gives it an attractive, creamy white appearance. After processing, the coconut milk is sent to an automatic filling system. Empty cans are cleaned and filled with a measured amount to keep the volume consistent. Metal lids are then sealed tightly to prevent air and microorganisms from entering. Depending on the can size, a modern production line can fill between 6,000 and 12,000 cans per hour. The sealed cans are heat-treated and cooled before moving to the finishing area. Here, workers attach the labels and print the production date and batch number. Each can is then checked for damage and proper sealing. Finally, the finished products are packed into cardboard boxes, sealed, and moved to storage before being exported. The uses of coconut flesh do not stop there. It can also be turned into coconut chips. Thin, crispy slices with a rich coconut aroma, commonly found in snack bags, cereals, yogurt, and desserts. To make this product, the coconut flesh is first separated from the shell, washed clean, and cleared of any loose fibers before being fed into a slicing machine. Sharp blades cut the white flesh into thin, even pieces that look light and delicate, almost like flower petals. The slices are then placed in a drying chamber to remove part of their moisture before being transferred to an oven at around 100 degrees Celsius for 50 to 60 minutes. Once the required crispness is reached, the coconut chips are cooled and inspected. Burnt or broken pieces are removed before the chips are weighed and sealed in airtight bags to keep them crispy for longer. Some batches are left with their natural flavor, while others may be seasoned with sugar, sea salt, cocoa, or spices. Besides coconut chips, coconut flesh can also be processed into coconut milk, coconut cream, or slowly cooked with sugar to make cocoa jam. But the value of a coconut does not lie only in its water or the white flesh inside. Even the rough, fibrous husk, once treated as waste after the fruit was opened, can enter its own production line and become a valuable green material. After being removed from the coconut, the husks are collected, lightly cleaned, and sent to the crushing and fiber separation area. Here, powerful steel gears tear the rough husks into smaller pieces. Inside the husk are two very different materials: long, strong, durable fibers and a softer, fine material known as cocoa peat. A coconut husk usually contains around 30% fiber and 70% cocoa peat. For this reason, the separation process must be powerful enough to break apart the husk, yet precise enough to preserve the length and strength of the fibers. The coconut fibers are then screened and sorted. Fibers longer than 150 millimeters are kept separately for rope production because they are easier to twist, less likely to break, and create stronger finished products. The fibers are then washed, sun-dried or mechanically dried to reduce moisture, and passed through an opening machine to separate any tangled clumps. Once clean and dry enough, the fibers are fed into a spinning machine. Small bundles are twisted together to form thin strands, and several of these strands are then tightly braided into thicker ropes. The finished rope has a rough, golden brown surface, but it is highly durable and performs well in damp conditions. Finally, the coconut fiber rope passes through an automatic winding system. Meter after meter is wrapped around large reels, forming heavy, tightly packed coils that are ready to be transported to craft workshops, farms, ports, or material warehouses. Long coconut fibers are not the only valuable material hidden inside the husk. Once the fibers are removed, the fine particles left behind become cocoa peat, a lightweight growing medium known for its ability to hold water. The dried husks are first fed into crushing machines, where steel gears break apart their tough structure and separate the long fibers from the softer material between them. The raw cocoa peat then passes through vibrating screens with different mesh sizes. Large husk fragments, short fibers, sand, soil, and other impurities are removed, while the finer particles continue along the production line. Next, the cleaned cocoa peat is dried under the sun or inside mechanical dryers until it reaches the required moisture level. The loose material is then placed in a hydraulic press and compressed under high pressure into pellets, square blocks, or rectangular bricks. This process reduces its volume dramatically, making the cocoa peat easier to stack, pack into containers, and transport across long distances. Once it reaches farms, nurseries, or greenhouses, the compressed block is simply soaked in water. Within a short time, it expands back into a soft, porous growing medium that helps plant roots develop while retaining moisture for longer. And now, let us return to the question that began this journey. If coconuts create so much value, why do millions of Filipino coconut farmers remain poor? The answer lies in a striking paradox. The farther a coconut moves from the farm, the more valuable it becomes. Inside factories, its water, flesh, oil, fiber, and shell are transformed into higher-priced products. Yet farmers at the beginning of this chain often sell only raw coconuts or copra, earning narrow margins while facing unstable prices, typhoons, pests, disease, and aging trees that reduce yields. The problem also has deep historical roots. The cocoa levy was collected with the promise of helping farmers, but for decades it became one of the country's most controversial economic issues. By 2020, its assets were valued at around 113.88 billion pesos, or roughly $2.3 billion US. So the coconut story is not only about a billion-dollar industry, it is also about whether more of that value can finally return to the people who grow and harvest the fruit beneath coconut trees across the Philippines today. The journey of the coconut is more than the story of a familiar tropical fruit. It is a powerful example of how a natural resource can be used almost completely, with every drop of water, piece of flesh, and strand of fiber transformed into something valuable. From the coastal coconut groves of the Philippines, this simple fruit has entered factories, global markets, and the daily lives of millions of people around the world. If you found this journey interesting, please like the video and subscribe to Mandarin Tech to discover more fascinating stories about technology, production, and the industries shaping our world.